There is water inside the Titanic that has never mixed with the ocean around it. Not in 10 years, not in 50, not in 113. The ship sank in 1912. It has been sitting under 3,800 meters of North Atlantic seawater for longer than most countries have had television, and yet inside certain compartments in the lower decks, the chemistry of the water is still distinct from the chemistry of everything surrounding it. Oxygen gradients that should have collapsed within years are still intact. Chemical boundaries that diffusion should have erased are still holding. Microbial ecosystems that could not survive in open ocean are thriving because the conditions they require, conditions that should not persist, are still present. This is not preservation. Preservation implies something was done to protect these spaces. Nothing was done. The ship sank, the ocean moved in, and somewhere in that process, the system failed to resolve itself. The ocean is in contact with these compartments. Water enters them continuously, and yet full integration has not happened, and the science of why it has not happened is stranger and more unsettling than the sinking itself. This is not a story about what the Titanic looked like when it went down. It is a story about what the ocean has been failing to do to it ever since, and what that failure reveals about the limits of the systems we assume are inevitable. When chemical sensors were deployed through fractured openings in the lower hull, the readings did not make sense. Oxygen concentration dropped sharply across distances of less than a meter. Redox conditions shifted at boundaries that should have been chemically invisible: a cracked bulkhead, a partially collapsed corridor, a gap between two deck plates. On one side, the chemistry resembled open ocean bottom water. On the other side, the chemistry resembled something else entirely. Something closer to what you would find in an isolated deep lake or a sealed sediment column. Not a structure that has been exposed to the North Atlantic for over a century. This should not remain. At 380 atmospheres of pressure, at temperatures just above freezing, the physical conditions at this depth are specifically those that eliminate variability. There is no thermal energy driving convection. There is no surface input creating turbulence. Diffusion operates continuously across every available surface, and diffusion is patient. Given enough time, diffusion alone should have flattened every chemical gradient across every boundary inside that ship, regardless of its geometry. The ocean does not stop working. It does not take breaks. It does not decide that a particular compartment is too difficult and move on. And yet the gradient is still there. The boundary is still there. The system has been in contact with the ocean for 113 years, and it has not resolved. That is not a minor anomaly. That is a fundamental failure of the process that is supposed to govern how environments integrate over time, happening in a structure that sits on the floor of one of the most studied bodies of water on Earth. Inside the oxygen-depleted compartments, sulfate-reducing bacteria dominate. They consume sulfate dissolved in seawater and produce hydrogen sulfide as a byproduct, driving the local chemistry into a deeply reductive state. The iron in the surrounding steel is being broken down not by oxidation, but by sulfur-driven reactions that hollow the metal from the interior outward, consuming it in a way that leaves the surface intact while removing structural integrity beneath. The environment in these spaces is not slowly degrading the ship. It is metabolizing it through a biological process that requires conditions the open ocean cannot sustain. 2 meters away, through a fractured bulkhead, the chemistry inverts entirely. Oxygen is present, iron-oxidizing bacteria take over. Corrosion follows an oxidative pathway, producing the visible rust formations that accumulate on exposed surfaces, the cascading orange structures that drip from the outer hull. These two systems, the anaerobic interior and the oxygen-present exterior, are chemically incompatible. In an open system, one would overwhelm the other. Mixing would eliminate the gradient. The boundary would collapse. The weaker chemistry would be absorbed by the stronger, and equilibrium would be reached. That has not happened. The boundary between these two environments has been maintained for over a century by the geometry of the ship itself by corridors that redirect flow, by compartments that limit circulation, by the same structural logic that was built to keep water out and is now in complete failure of its original purpose, keeping the ocean from fully moving in. The ship is no longer functioning as a ship, but it is still functioning as a system. And that system is resisting integration in ways its designers never intended and could not have predicted. Material analysis from multiple expeditions has produced a finding that structural engineers find deeply uncomfortable. The steel in the Titanic is not failing in any predictable pattern. It is failing according to the invisible chemical geography of the interior, not according to the age of the metal, not according to the original distribution of load, not according to any model of uniform degradation that can be mapped in advance. Sections near open fractures, where oxygen is present, show surface corrosion that is visible and measurable. Sections deeper inside, in the anaerobic zones, look intact from the outside, while the sulfur-driven reactions have been consuming them internally for decades. This creates a structural condition that cannot be assessed from observation alone. What appears stable may have lost most of its internal integrity. What appears heavily corroded may still be carrying load through intact interior cross-sections. The distribution of remaining strength across the wreck follows the chemistry, and the chemistry follows the geometry of water flow, and the geometry of water flow changes every time a new section collapses. Each structural failure alters the flow patterns inside, which alters the chemistry, which alters where degradation accelerates next. The system is not moving toward a stable end state. It is continuously reorganizing the conditions of its own degradation. This is why the Titanic cannot be assessed the way an engineering structure is normally assessed. It is not a structure with a predictable remaining lifespan. It is a system with a current configuration, and the current configuration is generating the conditions that will produce the next configuration in a sequence that cannot be fully modeled because the inputs are chemical and biological as much as they are mechanical. The deep current that crosses the seafloor at the wreck site is continuous. It carries oxygen, suspended particulate matter, and chemical compounds across the bottom, and when it encounters the Titanic, it does what fluid does. When it meets a large obstacle, it accelerates around the edges, fragments into smaller pathways at openings, and sends tendrils of flow into every available gap. Water enters the lower decks. Flow penetrates corridors, moves through collapsed sections, reaches into spaces that have been sealed since 1912. The ocean is not blocked from the interior. There is no barrier keeping it out. But entry is not integration. The flow that enters the lower decks loses momentum almost immediately. Corridors redirect it. Debris blocks it. Collapsed ceilings split it into paths too narrow to sustain circulation. What reaches the deepest compartments is not active flow. It is slow seepage, insufficient to drive the mixing that would equilibrate the chemistry across the boundary. The system receives water from the ocean without becoming the ocean. It is permanently in between, too open to be isolated, too restricted to be integrated, and partial openness is one of the most chemically complex states a system can occupy, because it sustains gradients indefinitely without ever resolving them. This is the condition that has defined the Titanic's interior for 113 years, and it is not a condition that trends toward resolution. As the ship continues to collapse, some openings widen and flow increases locally, but collapsing sections also create new debris fields that block other pathways. The geometry is changing, but the fundamental partial openness of the system is not. The ocean continues to fail to finish what it started, not because something is stopping it, but because the structure of the problem it is trying to solve keeps changing as it works on it. Chemical sampling inside certain compartments has revealed something that should not be possible in a flooded structure. The water is stratified, not turbulent, not uniform, vertically layered, with measurable density differences stacked within spaces that are smaller than a living room. Oxygen depletion alters the density of water slightly. Metal dissolution adds to it. Microbial metabolic byproducts contribute further. In a space where energy input is too low to drive mixing, these small density differences accumulate into stable vertical gradients. Heavier water settles, lighter water remains above, and they do not exchange. This stratification is self-reinforcing. The layering suppresses the mixing that would destroy the layering. The chemical conditions in the lower strata produce compounds that increase the density contrast, which stabilizes the boundary further. The biological communities in each layer are adapted to the chemistry of that layer and actively maintain the chemical conditions that define it. The system is not drifting toward equilibrium. It is actively diverging from it, generating more internal order over time, not less, developing more distinct chemical sub-environments, not fewer. This is not what happens in a passive environment being acted upon by external forces. This is a system that is generating its own structure from within. The interior of the Titanic is not simply resisting integration with the ocean. It is producing conditions the ocean cannot replicate, sustaining chemistry the ocean cannot sustain, and doing it continuously, using the energy inputs provided by the very processes microbial metabolism, metal dissolution, sediment accumulation that are also slowly consuming it. Since 1912, fine particles have been settling through 3,800 meters of water column and accumulating on every horizontal surface inside the hull. The rate is slow millimeters per decade in the most sheltered spaces, but it is continuous, and over a century it has produced measurable changes in the interior geometry. Openings that were documented in early expeditions are narrower now. Corridors that researchers could once access with instrumentation have been partially sealed by accumulated sediment. The interior of the ship is not a fixed space being degraded. It is a space whose geometry is being actively rewritten by what falls into it. Within each sediment layer, oxygen penetrates only a few millimeters from the upper surface before being completely consumed by microbial activity. Below that thin boundary, conditions are fully anoxic. Every new centimeter of sediment adds a new anoxic zone, reduces the connectivity between the water above and the material below, and slows the exchange that would otherwise move chemistry toward equilibrium. The sediment is not burying the ship passively. It is chemically insulating the most vulnerable surfaces, layer by layer, at a rate that is measurably slowing the integration the ocean has been attempting for over a century. The geometry the ship was built with is gone. What exists now is a different geometry, one shaped not by engineers in Belfast in 1909, but by 113 years of particle physics, microbial chemistry, and structural collapse. And this new geometry is generating the flow patterns that determine where chemistry differentiates, where degradation accelerates, and where conditions persist that should have disappeared decades ago. The ship is not being shaped by the ocean. The ship is shaping what the ocean can do to it. Long-term monitoring data from the wreck site contains a pattern that took years to identify because it contradicts the intuitive model of how large structures degrade. The Titanic does not change steadily. It holds sometimes for months, sometimes for years, and then it changes rapidly. Sensor readings inside monitored compartments show extended periods where chemical concentrations, sediment levels, and structural indicators hold within narrow ranges, showing no measurable trend in either direction. And then, a boundary fails, a bulkhead opens, a deck plate shifts, and the readings change within days in ways that had shown no prior signal. What follows a boundary failure is not gradual adjustment. It is cascade. New oxygen exposure triggers oxidation reactions that had been chemically suppressed for decades. Microbial communities that were stable in anaerobic conditions crash and are replaced by entirely different populations within weeks. Structural elements that appeared intact because their exterior surfaces were protected by the anaerobic chemistry that had been consuming them from within, suddenly lose the internal support they needed to hold the load they were carrying. The failure, when it comes, is fast. The system had been accumulating imbalance invisibly, holding it in a state that appeared stable, and then released it entirely when a single boundary was no longer sufficient to contain it. This is delayed instability, and it is one of the most difficult system behaviors to detect, because the signal is invisible until the moment it is not. The system does not warn you, it holds, and then it does not. The expectation, when researchers first began systematic study of the wreck's interior chemistry, was that the system would show signs of convergence, that the chemical gradients would be smaller than they were a decade prior, that integration with the surrounding ocean would be measurably more complete, that the direction of change would be clearly toward equilibrium. That expectation has not been confirmed. What the data shows instead is that the interior of the Titanic is becoming more differentiated over time, not less. The number of chemically distinct microenvironments inside the wreck is not decreasing. The boundaries between them are not becoming less defined. In some regions, new boundaries are forming that did not exist in earlier survey data. The system is not converging, it is fragmenting, not in the sense of falling apart, but in the sense of developing more internal complexity, more distinct substates, more local equilibria that exist in tension with each other and with the ocean outside. Some compartments are nearly fully integrated with the surrounding water. The chemistry inside them is indistinguishable from the chemistry outside, and the structural material in those zones is heavily degraded. Others remain in states that have no analog in the open ocean, sustaining conditions that require the specific combination of enclosure, flow restriction, biological activity, and sediment accumulation that only the Titanic's interior geometry can provide. This is not a system trending toward a single outcome. It is a system generating multiple, simultaneous outcomes in different locations, driven by local conditions that are themselves changing. The ocean has been working on this problem for 113 years, and the problem has not become simpler. It has become more complex. The Titanic is not a shipwreck in any sense that the word usually implies. A wreck is a passive object being acted upon by an environment. What exists at 3,800 meters in the North Atlantic is something the scientific vocabulary does not have a precise term for a structure that has become an environment that generates conditions which would not otherwise exist in that location, that sustains chemistry the surrounding ocean cannot sustain, and that alters the behavior of the ocean around it as much as the ocean alters it. Flow adapts to its geometry, chemistry responds to its flow, biology reshapes the chemistry, and the structure in turn changes what the biology and chemistry and flow are capable of doing. These are not one-directional processes. They are mutual. Neither side is winning. What the lower decks contain is not a record of what the ocean does to structures over time. It is a record of what happens when a structure is complex enough that the ocean cannot process it efficiently, when the geometry keeps redirecting the flow, when the chemistry keeps generating new gradients faster than diffusion can collapse them, when the biology keeps producing compounds that alter the conditions of its own environment, when the sediment keeps rewriting the space that all of these processes are operating in. The system does not trend towards simplicity. It generates complexity, and complexity resists the equilibrium that is supposed to be inevitable. The question researchers are now asking is not when the Titanic will be gone. It is what the system will look like when the large structural elements are no longer present to constrain it, whether the chemical and biological processes will persist in the sediment, whether the gradients will survive in a new form, whether what the ship built inside itself will outlast the ship. The ocean has been working on this for 113 years. It is not finished, and based on the trajectory of the system's internal complexity, there is no clear indication of when finished will arrive. Subscribe to Sunken Realms Deep, where the history stopped and the system keeps going.